Hello everybody, welcome back to the channel. Hope everyone's doing all right today. So today we're going to be talking about how to set up multiplayer and persistence in verse. Very difficult topic, but I'm going to try to keep it as simple as possible since this course was designed for newer people. So we've got a new map set up here, just the blank default map. There's nothing on it except the spawners. So in your Verse Explorer, we're going to go ahead and create a couple files to get us started. We're going to create a custom player class. And we'll create that one as empty because we're not going to need a device for it. We're also going to create us a persistence class. We're also going to create a persistence class, which is where we're going to be keeping all of our data that is saved for the players, as well as the functions that go along with it. So then I want two main files that are just going to have workable code in it, because as discussed in the previous video, one of my biggest pet peeves with the multiplayer tutorials is they only show you how to do it when you're working in a single file. Once it starts getting broken up into multiples and bigger programs, people are having issues. So we're going to go ahead and do at least two just so you can see how that actually works. So let's have a game manager. And I don't know. I guess it doesn't really matter what I call the other one. We'll just call it an elimination manager, even though we're not going to be eliminating anything here. All right, so we're going to start with our custom player class here. This up here is just, I always just throw the same ones in there because these are the ones I use most commonly. Not going to use all of them in this. I just always copy paste them anytime I have a new file just to save me trouble down the line. So starting with the class, we're just going to name it custom player. And it is going to be a class. Just make sure you always include the unique specifier here when creating a custom class. And since this class is going to be managing your players, well, obviously you want it to be for a player. So the first thing we're going to include is player of type player. And that way, anytime we reference this player within it, it knows we're talking about an actual player, is all that is. Now, for this tutorial, it's still going along with the death run examples we've been using in previous videos. What it's going to be doing is you're going to have a vault that players can get into after they've collected all of the hidden items throughout the map that just gives them bonus rewards. So to track that, each player, it needs to keep track of which of those hidden items they've found. So variable secret number 1, type logic, equals false, because they have not found that item yet. And I did not need to put a space there. And let's have, I guess, 5 hidden objects would be good. So now we need a function that is going to check whether or not all these items are true or false. And if they do have all of the items, it's going to open the vault. So we'll create that now. We'll just call it check vault. Void equals, because we're not returning anything. So if secret 1 is equal to true, those are supposed to be uppercase. And you can have multiple if conditions in here. So if 1 is equal to true, and 2 is equal to true, and 3 is equal to true, etc., etc. So only if all of these statements are correct will it proceed to the next. So if all of those true, what do we want it to do? Well, we want it to identify that the player now has access to the vault, which we also need a place to save that. So another variable, we'll just call it unlocked. And by default is false. So if all of those statements are correct, Then we will set the unlocked status to true. Now, each player is going to have its own set of these values, secrets 1 through 5 and unlocked. So you don't want to go changing them in your game manager, or it's going to change them for everybody. So the function that actually changes them needs to go ahead and be here in this class. So we'll just create some functions for that. Now, again, I'm intentionally going to be doing this very inefficiently. Because I want it to be as simple as possible so people understand how it works. Normally, you could set up one function that could do all of these based on the input given, yada, yada, yada. But again, I'm not worried about efficiency here. I want people to understand how it's working. So I'm going to go ahead and just create 5 separate functions here. So I just want to throw that out there. It is intentionally inefficient, but I want it to be as simple as possible. So we'll just create 5 functions that look almost identical. So we'll do update secret 1. And whenever that function gets called, it will set secret 1 equal to true. Forgot the void there. And we'll copy that and do the same for secrets 2, 3, 4, and 5. So every time you collect one of the hidden items, we can have it call one of these functions to update that item. But then we also need to check the vault to see if that was the last item they were missing. So we can either have a loop running nonstop, say every 3 to 5 seconds, checking their status, or we can just go ahead and put it in here, which is the easier way. So when you collect the hidden item, not only do you want to update that one, you also want to check and see if the vault is now open. So we just include the check vault in each of these functions. And that takes care of it for setting up the basic custom player on this map, because that's all we're tracking is what the hidden items they've found and whether or not they have access to the vault. And bigger maps, you could have a player's custom health, custom level, custom experience, attack, speed, whatever stat each player has would be right here. I almost said stored. It definitely is not stored right here, and we'll get to that when we start talking about the persistence. It is simply defined here. But to make sure this is all working first, we're going to go ahead and jump back into our game manager and set up the basics there. So again, I just always put the same ones up here just because you never know which ones I'm going to need. It's a bit excessive since I won't be using all of them in this one, but it's fine. So for those of you who already know how to work with tags, this part will be simple. If you don't know how to work with tags, I've got a video on that, so go ahead and go take a look at it. But the easiest way to initialize your players as they spawn in and join the map is through having tags on your spawn pad. So we're just going to go ahead and create a spawner tag here. So within the game manager, we need to go ahead and set up our editables, which is going to be our 5 hidden objects that we're tracking, along with the vault itself. So we'll just call it hidden objects 1 through 5. It is type collectible object device. And then we'll just copy and paste that and change the numbers. And our vault itself, we're going to use a barrier for. We'll just call it vault. And that should be all the editables we need for this test. So the first thing when the map starts is we need to initialize the spawners. That's how we're tracking the players as they join the game and assigning the properties to them. So init spawners. And we have not defined that function yet. So go ahead and create that. All right, so these are all of the initialized functions here whenever you're using tags. I'm not going to go through the whole process of writing these out and explaining how they work again, because I've got an entire video already on this channel about tags and how to set them up. So if you're not sure how to make this right here, you can either freeze the video for a minute and just copy it in, or preferably go back and watch that video so you actually understand how they work. But one thing I did forget to do is actually create this custom player map up here. So we'll go do that real quick. So up here after your editable, I'm going to create our custom players map. And this is where the information is actually being stored. So every time you create an instance of this custom player class, it goes into this map right here. So this right here, this one line we're writing, is the key to the entire multiplayer setup. So it's just variable, whatever you want to name your map, what your key is for the map. So every item, again, this was talked about in the previous video. So all a map is a set of key value pairs. So your key is going to be player. Whatever player, when something is added to this map, it's going to store their player, and then it's going to store their custom player class that you made. And from then on, anytime you access that player, it's going to access the custom player information that was associated with it. So that's what this is. Most important part of the multiplayer setup right here. All right, so as we collect the coins, it's going to update that they've been collected, and then check if the vault is open, and then open it if they have all been collected. So let's go ahead and start creating those. Again, this could all be done far more efficiently. You could have one function that handles all of it, but this is intended for newer players. So once again, I'm going to write it all out so that it can actually be seen how they are working, and if you want to go back and make it more efficient, feel free. So we're going to have multiple functions here. So unlock the first area, or first hidden object. It'll need the player that did it, or in this case, an agent. So we'll just call it A of type agent. Not returning anything. And this is where it's going to get confusing for a couple people here, because you will need to check a few things first. First of all, your map is using players, not agents. A player is a type of agent, but it's not the only type. Your NPCs are agents. Your wildlife are agents. There's several other types of agents. So the first thing we have to do is make sure that the agent that triggered this function is actually a player. So if player type equals player of A is how we do that. So we're creating our own custom object called player. And if the A that we sent in is a player, then it will create this. That's all you have to do to check whether or not the agent is a player, is all we've done there. And so then the next step before we can do anything with this function is we have to say, hey, this player that we just created, are they in the map that we created up here? Which, again, as long as your spawners are set up correctly, every actual player should be in that map. So if this fails, you've got bigger issues. But this shouldn't fail, as long as everything was set up correctly. So we will just call them custom player. We do it the exact same way. So here, if the object in the brackets is a player, it'll create it. Same thing here. So our map is called custom players. And then the player that we just created. So same thing. If the player from up here is in our custom players, it creates a new variable called custom player for us to use. So we've just converted the entity that triggered this function into a custom player that we can actually use, is what we've done here. And again, I'm oversimplifying this. There's plenty of other videos that breeze through this a lot quicker, but y'all are going to get tired of hearing me repeat it. But this was designed for newer people and or people that are struggling to get this set up, because I'm still seeing so many people on the forums complain that they can't get their multiplayer working. So I will be yapping a lot more than really necessary in this video. But assuming both of those are true, we're going to call the unlock function that we created in our custom player. So for that custom player we just made, dot, and our function was right here, update secret 1. And that's it. Anytime that coin is collected, if the agent that triggered this function is in your custom players map, it updates their custom player information to true and checks the vault for them. And we're just going to, again, this could have been done with one function, but we're writing it out. So we're going to go ahead and need to copy this 4 times for each of the functions. And make sure we update the name as well as which function is being called. All right, so now we just need to actually call those functions. So we've got our editables here. Hidden object 1. So hidden object 1. Collected event. .subscribe. And all that is anytime the object is collected, it's going to trigger our designated function and send whichever agent collected it. Which is why we are required to have an agent here. So we're doing unlock 1. And that's it. We do the same thing for the other 4. Okay, so let's jump over into the editor now and get this set up. We only need the one spawner for the test here. So make sure that is tagged. Oh, got to build the code first. Build your verse code. And then make sure your player spawner is tagged. So add, search for tag, verse tag markup, and we'll add the spawner tag that we created. All right, now we need 5 collectibles. And then we need a barrier device. And one thing to note on here is that we need to make sure this is set to invisible when ignored. Yeah. Oh, come to think of it, I forgot to actually put the barrier device in the code. Oops. So we need to go back and do that real quick. So yes, we've unlocked all of these areas, but we never actually did the barrier device. So in each of these functions, once that's called, again, we need to check and see whether or not the barrier has been unlocked. And if it has, we need to actually unlock it. So if custom player, what did I call it again? Unlocked. So if custom player dot unlocked is equal to true, then we want to unlock the barrier, which we called vault, I believe. Yes, vault. So we're going to add them to the ignore list, and that's going to be the person that we put in. And that's all that is. So if the custom player here, their value for the unlocked status is equal to true, then that barrier is going to start ignoring them. And since we checked the little box, it's going to make it invisible to them as well. So they won't be able to see it, and they can just walk through it. And we'll go ahead and add that to all of the coin functions. Rebuild our verse code here. And go ahead and drag in our game manager and attach all of those. So just attach all of our collectible objects and then attach the barrier, and then we will launch it and see how it's working. Okay, so we are in the game, and assuming I set everything up correctly, as soon as I pick up these 5 coins, that barrier should vanish. Ta-da! It is gone, cannot touch it, cannot see it. And that should be it, right? Because that's going to work for every player in your map. It's only going to disappear for the ones who collected the coins. Everyone else won't be able to get inside. So we're done, right? No, not even close. What happens if you reload your map, even though you've collected all the coins? Guess what? Everything was reset back to the original. Are you going to want them to have to collect the coins every time they play in order to get into the vault, or do you want it to be something that is saved? Well, that's where persistable data comes in, which is what we're going to be getting into next. And again, this is very important for people trying to make more advanced maps, because this isn't just about collecting coins and barriers. It's anything you want to save. Their progress, their level, their experience, any custom data that player has earned while playing can be saved with persistence. So let's go ahead and jump back into Verse and take a look at that. So back in the persistence folder, we'll go ahead and add in our normal dependencies. So just like we had our custom player map in our main folder, we're going to need another map here. But in this case, we're using a weak map. If you don't know the difference between a map and a weak map, again, watch my previous video. It was an entire video of nothing but discussing the mechanics behind setting up multiplayer. So, but you can kind of think of it as a part 1 to this video in a way. So we're going to call it our save data map of type weak map. And our key is once again going to be a player. And our value is going to be our save data, which we haven't created the save data yet. We're going to be doing that next. So I might just comment this out to get rid of the error. But even though it's a weak map, it is still a map by definition. So go ahead and, whoop, wrong button. Go ahead and have that in there. And yeah, we'll just comment it out for now. So the error's gone. And now we create that save data, which is a class. And then here's the big thing. As far as if you want it to be savable and last between rounds, you have to include persistable here. That's all it is this one designated here. Persistable is what lets it be saved. And you don't want it being changed by anything outside of this, so make sure you include final as well. And then what are we saving? Any information that you are actually saving for the player is just written out right here. Their level, their attack bonuses, any custom information that player has. So first thing, hidden object 1. Whoop. And it's type of logic. And by default, it is false. And do the same thing for the others. And then the vault status. All right. And that is now savable. But the issue right now is because this save data is a class by itself, anytime we update the save data, we're going to have to re-give it all of this information. You create a class, you say, hidden object, you have to give it the hidden object 1, the 2, the 3, the unlocked, every time. Well, there's a way around that, and that's what's called a constructor. So what a constructor is when you have multiple objects like this, it already has that information in there. And so if you just want to, instead of having to give it all of these items over and over and over and over, you only have to give it the one you want to change, and it'll keep the previous values for all of the other items. So that takes a minute to set up, but it's going to save you so much time throughout the rest of your program, especially once you get into much bigger games. So we'll go ahead and set that up now, and we're going to call it make save data. And for a constructor, you just include this parameter definition here at the front. And we're going to take in the save data we previously had up here, and we'll call this instance of it SD just to keep it simple. And make sure you include transacts. And it's going to return a new set of save data. So again, it's going to be handling every item that's currently in our save data. So to create a new set of save data, we're going to need to go ahead and include the items here. So we got hidden object 1, and we're going to set it equal to our previous save data. And we're going to do that for the rest of them as well. So again, what we've just created here, anytime we call make save data, it's going to create a new set of save data, and by default, it's going to assign all of the values to the previous sets. So if previously we had not found object number 1, when we create the new data, it's going to say we still have not found it. But when we go to actually call this function in our program, we have the option to change values. So say we found coin number 4. When we call it, we can say, hey, change this one to true, and it'll change it to true and change all of the others to what they previously were. So it's just a much easier way for us to update our data within the code. So you only have to change one item instead of reassigning everything in the class if you didn't have this constructor. So again, it takes a minute to set up, and hopefully it's not too confusing. But this is just a way to very easily update your data without repetitive code. Now we come into the part that's probably going to confuse a lot of people who don't have much coding experience. And that's going to be that we are creating what's called an extension function. Now, anyone who's been through this series should at least have a basic understanding of what a class is. What we haven't really touched on is a lot of the terms that we're using from the game itself are already classes. In this instance, we're talking about players. Players, agents, devices, those are already classes. Were previously created by the system. If we go into the digest for player, it's a class created by the system that already has functions in it. In this case, is active. But that's the only function in it that we're able to use. Now, you could create your own system for managing it with your players, how to call this function on them. But since it's already an existing class, if we were able to add a new function to that class, we could then call that function on any player that we wanted, which is what an extension function is. It lets us add a new function to an existing class. So if we add a function that lets us get our player's data to the player class itself, then any player in the game will be able to call that class, which is exactly what we're going to do here. So I'm going to go slow with it, but that's just a general overview of how it works. We're going to be adding new functions to the default player class that Unreal has given us. And in this case, we're going to be adding functions to get the data and set the data. So let's go ahead and create the function itself first. And so we'll call it get save data. And we're not sending anything in, so we don't need that because each player is going to have its own. But we will be returning a set of saved data. And that was supposed to be an equals. So far it looks like a normal function, correct? Well, there's one thing we've got to go back and do to make it an extension function. And that's going to be to mark what existing class we are going to be extending from, which in this case is our player. And that goes before the function. So it'll be a player of type player. And I forgot the parentheses. So in parentheses, player of type player. And so with that, any player is going to be able to use this function. All right, so first things first, we need to make sure if the player is active in our map. So if they're not active, so again, we have an isActive function provided in the player class already. And so if they're not active, we're just going to return save data, no changes, no nothing. So next, assuming they are active, we will create a new set of data, SD, and it will be equal to save data map for the player. And then we would return the save data that it found, which is SD. And if neither of those are true, we'll create a new set of save data. And again, I know this looks confusing. I'm going to go back and talk about it all once I'm finished typing it. Sorry, I am slow typing. Type equals save data. If set save data map for the player equal to that new save data. And that bracket is not where it's supposed to be. Else. Print error. And then return new save data. Return the new save data. Okay. Why am I getting an error? Oh, I forgot that was still commented out. There we go. Okay, I know that seems like a lot, so let's walk through it real quick. So we've created a function called getSaveData and attached it to the player class. So anything of class player now has access to this function. What the function does is, first thing, it's going to check if the player is active. If the player is not currently in your map, it's just going to return the default save data. If the player is active in your map, it's going to get the player's save data information from this map up here and then return it. So any thing that's been previously changed anytime the players played the map before is stored in their player map's data. So it's going to get their previous data and return it, which is how we're keeping up with saved data. So if the player is active in the map, but does not have any previous data in the map, is what the final one is. It's going to create them a new set of save data and add them to that map. So a new save data of type default data information, which is the false, set it into the save data map. If it couldn't add for some reason, it'll give us an error, which is all the print statement's for. But assuming everything went through, it would then return their new save data. That's all that. So that is what this is getting the player's information. It does nothing if they're not active. It gets their previous information if they've played before. And if they haven't played before, it gives them a brand new set of information. Is what the getSaveData function is. Now we need to go through and do the same thing for setting the data, which will be updating their data every time they do something. So anytime they collected one of those coins, we can call the SaveData function to update their persistable data so that the system never forgets they collected that coin. And once again, this is going to be a extension function because we want any player or anyone of a type player class to have access to this. Now this time we will need to be inputting informations. What we're going to be sending is, again, it's not going to let us just jump in from an outside function and set one. No, we have to create a new set of save data for them and then replace the existing one in the map. So we're going to have to send in a whole set of save data, which will just be their new save data. We can use the same name here. And it is of type save data. All right, so first thing, once again, we need to check if that player is even in the map. Again, it's something that shouldn't happen, but it does from time to time where the game will randomly think it's something that's been caused by a player that isn't there. So it's always just a good bug check to prevent errors. So if not player.isActive, and we just want to return. So if the player in question does not exist, just close the function and move on. However, if the player does exist, we're going to set the save data for that player equal to the new save data that we put in. And if for some reason that doesn't work, we'll just print error. All right, so quick cover on this. So we've created another extension function for the class of player called setSaveData. It's going to take in a new set of data. So anybody in the map, or anything, any object, any agent that is assigned to the player class has a new function where they can pass in a whole new set of data. If that player is not currently active in the map, we do nothing and just close the function. If the player is active in the map, it's going to take the new data that we sent in and replace their existing data. Again, you can't just go in and change this to true, change this to true. You have to replace it. So it's going to find them in the map. and replace their existing data with the new data you sent in, which again is why we created this constructor up here, because without the constructor, you would have to give it a value for all 6 of these every time you tried to update their data, which it wouldn't be too bad here, because again, it's only 6 objects. But imagine you had like an RPG where every player had experience, had HP, had attack, had stamina, had run speed, had intelligence, wisdom, whatever. You could have 500 custom variables for each player. And every time you updated one of those stats, you had to give it all 500 stats. That is insane. Versus creating this instructor one time, creating this constructor one time where you only have to tell it whatever value changed, and then it just replaces everything else with the previous value. So again, constructors in a very probably more important here than the persistence in a lot of ways. But that's going to be how the set save data function works. And for those of you who've seen other videos and were curious about getters and setters that people keep talking about, well, that's this. It's not good practice to go in and just directly change something. You want to get the previous data or set the new data. You don't just want to send it and say, hey, go change this. But that's all for setting up your persistence data class. This right here allows us to save all of these values, update all of these values, get a reference to all these values. This little page right here is all of it. Now, to make this actually work with the custom player, we need to go back and change a few things in the custom player class itself. Okay, so now we're back into the custom player. Anytime your map starts, it's going to go ahead and create your custom players map and add these players. But the thing now is we don't always want them to start at false. If they have played the map before, they will have existing persistence data that we need to set it as the starting point instead. So to do that, we need to go ahead and create an initialize function. So we'll just call it init. And we're not returning anything. So we're going to create a set of save data for the player. And it'll be for our player, which was defined up here. And it has access to, since it is a player, it has access to that function we just created. So get save data. So that right there takes this player's existing data and puts it here. So now we just need to take that data and assign it to our default values up here. So have a function, we'll just call it get current stats. So we need to go create that function real quick. Oh, we need to pass in the data though, otherwise it won't know what to do. Duh. And that I should be capitalized. Again, just forgive me for my terrible typing skills. And it'll take in SD of type save data. And we're not returning anything. Okay, so now we just need to set all of these values up here to the stored value in SD. So set secret1 equal to SD dot, what did I call it in there? Did I call it secret or hidden? I called it hidden. So hidden object 1. And we do that again for all of the others. And we need to do it for the vault as well. All right, so anytime we call this initialize function, it's going to get their existing saved data and then set the current data we're using to that saved data, which should be the first thing that happens when they spawn into the map. So let's go back to our game manager to where they do actually first spawn into the map, which will be right here in our initialize player function. So we'll add custom player. .init. That's it. So whenever the player is initialized at the start of the map, it's going to go ahead and update to their stats to whatever they were at when they left the map the previous time. So let's go ahead and jump into the game and test that. Oops, I forgot something. We did initialize it, but we didn't check if the vault was open. Actually, I don't even need to type this out. I can just copy it from below. It's the exact same function. So copy that up here. So if the unlocked status is true, we will add the ignore list. But let's see, up here I used agents. Okay. Now for the part that's going to probably annoy a lot of people. This right here looks so simple, right? You just update the secret for each one. Unfortunately, that's not going to allow you to save it. We have to actually use the set function we just created. Can't just go in and manually change it. We have to create a new set of data and then replace the old data with the new data anytime we want to update it. So let's go ahead and start on that. So we're going to create save data. And it's going to be equal to the player's previous data. So player dot get save data. So we have created SD, which is equal to their previous data or their current save data. Then we're going to go ahead and get their current stats to make sure nothing has been changed since the previous time the data was updated. Now we're going to create new save data. And it's going to be of type save data. And here's where that constructor is going to come into play. So make save data. Okay. So again, I know I've mentioned this several times, but normally if you did not have that constructor right here, when you create this new save data, you would have to put in a value for every item that is in save data, all 5 secrets and the unlocked and any other data. But because we have that constructor for make save data, we only have to give it an item we want to change. And the rest of it's going to replace with the existing data. So in this case, the only thing that's changing is going to be the first hidden object. And it is being changed to true. Oh, I didn't finish writing it out. I got too busy talking. Needed to identify that it was a constructor and that we're passing in the save data. And why did I have a period in there? There we go. So the make save data function did before just removed so much work for us because we can just update what we want to update and don't have to worry about the rest of it. So we've created a new set of data that has the hidden object in there. We need to actually go back and assign it. So to assign it, just like we had a get save data, we also did create a set save data function. So player.set save data. And it's going to be the new save data we just created. So the data we have stored in our persistence file has now been updated for that to be permanently true unless we go back and change it. Even if you leave the game, when you come back, that will still be true instead of the default value of false. And that is how you save the data. We do still need to go ahead and make sure it's changed up here as well, though. So, I mean, we could put back in the set secret equal to true that we had before, but just to be safe, instead of just automatically changing it to true, like hard coding it in, it's usually better to just set it to the value that you just created here. So we'll put back in the set secret one that we had before, but instead of just directly setting it to true, we'll set it to the persistence data's value, which will be our new save data dot hidden object 1. And that should have been capitalized. And again, I know this right here looks more complicated than this, but again, you could easily put it into one function just when you refactor it. Again, I'm just typing it all out so it's easier to understand, easier to see for the newer people. Normally, when you're doing this, especially when you start getting more values, you're actually going to want to create what's called a player's map, not a player's map, a stats table. Do I even want to get into that? No, that's going to be, I'm already covering too many topics for newer people. So there's plenty of videos out there on persistence. Once you learn how it works, go look at some of the more advanced videos and start looking how to set up stats tables and everything in here, because that will make your coding a lot more efficient. But again, this is just for the basics. So no, I'm not going to get into that. All right. So now we'll just replace it all down here and go back through and change it to the correct values. And this is another one. I know it's time consuming and boring to go through and make these changes here, But this is probably one of the most common places I see people mess up is they start rushing through this and forget to change one. And then it just throws off their entire program. And they spend 10 hours trying to find the one item they missed. I mean, like right there, I went through and y'all saw me change all those, right? I'm not done. I didn't change it over here. So you got to make sure that everything lines up, which is why it's usually a lot simpler to refactor your code to as little code as possible, so there's less chance of having errors like that. But it's easier to read right here. And again, y'all are going to get tired of me repeating myself, but I'm trying not to just sit here and code in silence while making a video, even if I'm rambling as a result. Did I change everything? I think I did. Okay, so assuming I didn't miss anything when I was going through and updating all that, yeah, unlocked, secret. Okay, let's go push first changes and see if it's working. So collect all 5 coins, and the barrier disappeared. Let us leave the game, and if it's working, then when we come back, the barrier should still be gone. So start game. Ta-da! So the information from our previous round does now save over. And again, it's not limited to coins and barriers. Any stat that you want an individual player to have can be stored in the same way. Now then, the problem, well, by doing it this way, the problem would fix itself. But I just want to give a quick example of why we are doing it this way. And that is, go back to how we had it earlier before we created the persistence, where we just had the game manager and the custom player manager. We were just setting this directly. Let's go ahead and set a couple of those back to that. We'll comment we'll just comment all the code we just created out. All right, so that's all commented out. It's going to work exactly like it did previously. So what I'm seeing, and this is what most of the tutorials out there in multiplayer are doing. They have you set up your game manager. They have you set up your custom player class, where it's just updated automatically, and that's fine on 2 conditions. One, it's only going to work if you're not wanting persistable data. If it's indicted, each run is intended to be its own game, you don't want to save any data between them, then this will work. And then condition 2 is it has to be a smaller game with only one file where you're running the actual game processes. You're just your game manager. When you get into bigger games that have multiple, sometimes even dozens of files and classes and devices, this will not work. And I'll show you why. All right, so we're just going to copy everything inside the game manager here and put it in our elimination manager. And, oh, I didn't copy see, that right there is why I always copy the dependencies. Is because characters is one of the most common ones I use, and I just use all of these a lot. So I just always copy the same dependencies. Yeah, okay, so bug gone. So obviously this is not realistic. Normally, anytime you create a separate verse device, it's going to be for a different purpose. So it's definitely not going to be the same code in it, but this is just to show an example. So if you collect it in this folder, it's not going to update it in the other folder kind of thing. So we'll just do 1 and 2 in this one and do 3, 4, 5 in this one. So if you collect all of the coins, these 3 will update in this folder's custom player class, or in this map right here. And if we do it in the other one, it's only going to update coin 1 and 2. And this is where people are running into errors, is they're thinking that they're connected and they're not. So if you think that you're still collecting all 5, even though it's being done in 2 separate areas, right? So it should unlock the barrier. Well, let's go take a look. So we collect all 5 coins, and the barrier does not open. Again, I covered this in a lot of detail, basically ranting in my previous video about this, because this is what annoys me about most of the tutorial videos that are out there on multiplayer, and it's confusing so many people, is all of the examples they give just use the most basic, simplest structure, which does not scale up. So even though you're collecting all 5, the information in this custom players map is a completely separate instance from the information in this custom players map. So they don't communicate. So this one will never, no matter how many times you collect all the coins, if you have the information in different areas, it'll never reach all 5. And it's the same thing I see it most in like RPG maps that people are trying to make more than anything, because they'll have, say, a quest manager and an elimination manager. Well, both of those grant experience. So say in your elimination, you have a function set up to give your player experience anytime they kill a monster. Great. They kill 5 or 6 monsters, and then they go to turn in a quest, thinking it's going to give them the rest of the experience they need to level up. Well, suddenly it resets their experience to 0 and starts over from there. That's because since they're in 2 different verse classes and devices, they're stored separately. So you basically have 2 completely separate experience meters. And so it's just bad to do it that way. And it annoys me that none of the other tutorials are talking about that. If you're going to have a larger program with multiple devices that serve multiple functions, you need to go ahead and set it up with getters and setters. Even if you don't want it to save between between games, you can just remove the persistable here and it won't save it. But if you don't have a centralized location for that data, and then have your custom players getting that data and from that location, then it's going to create them new data for every class. And all of your numbers are just going to be wrong as you go throughout the game. So I'm hoping I'm not ranting too much on this. It's just I've seen dozens of tutorial videos on custom players and multiplayer that only covers this first part and only use the smallest example, and it's honestly causing more harm than good as far as getting new players to understand it. So if you take anything away from this at all, it's that you need to set up a centralized location to store the data for the players. And then in your custom player class, don't just hard set that data to true or false or 50 or 100 or whatever number and value it is. Instead, have a getter and a setter function to get that data from the centralized location and to update the data in that centralized location. Otherwise, the more classes you add to your program, the more bugs you're going to have. So yeah, that's pretty much it. Before we end, I want to let's go ahead and launch a multiplayer session just to show that it is working for multiple players. Okay, so we are back in with a multiplayer game now. Go ahead and collect all the coins real quick. And the barrier has disappeared for me. But as you can see, it is still very much there for the other players in the game. So what happens if we leave the game and come back? If everything's working correctly, the barrier should still be missing for me and still be there for them. Let's find out. Okay, so spawn back in. As you can see, the barrier is still missing for me. And still very much there for everyone else. So everything's working as intended. The multiplayer's working, custom player's working, the save data's working. And I know some of the concepts might be a little hard to understand for some of the newer people, but this is about as clear as I can make it, unfortunately. I mean, like I said, there's ways to make it far more efficient, reducing all of these functions down to 1 and using stats tables, etc., etc. But really not that much code to get all of this running. It's just a matter of understanding how it works and then simplifying it in a way that works best for you. Which, unfortunately, I can't help with that part. But hopefully this will help some people to better understand how to set up the multiplayer in their maps. So that'll be it for this video. I hope y'all learned what you needed to from it. It's the end of this series, but I will continue to keep making more tutorials. They just will be individual videos. So if y'all enjoyed the video, I think y'all know what to do at this point. Every little bit helps, even if you turn off notifications. More people subscribe, more views I get, the more content I can make. So again, if you enjoy, hey, hit the button.